As we begin the next section, it'd be a good idea to recap the derivative rules that we have learned so far because we're going to be adding to this list in 3.3. So the derivative rules, otherwise known as the shortcuts, right, the patterns, the formulas for different situations, started back right at the end of chapter 2. And so we had these all for polynomials at that point. The derivative of c equals 0, any constant. This was the power rule here. The derivative d over dx, x raised to the n is nx to the n minus 1. This is the constant multiple rule. When you've got a constant times a function, that constant just carries along and you take the derivative of the function, not to be confused with the derivative of the constant by itself, constant multiple. Then we have the rule whenever you are adding or subtracting two functions. So if you're looking at f of x plus or minus g of x, then you take the derivative of each one on its own, f prime of x either plus or minus g prime of x. Okay, so we're pretty familiar with those at this point. More recently, we learned the derivatives for exponentials and logs. And this is where our list is at right now. So we learned the derivative of e to the x is simply itself e to the x. The more general exponential is b, any base raised to the x. And it turns out that derivative is b to the x times the natural log of b. We learned the derivative of natural log of x is 1 over x. It's kind of a peculiar one. And then any other log with base b, its derivative is 1 over x natural log of b, like that. Okay, so it's time to advance. What you might notice, where we're going to go next, a while back we learned about adding and subtracting two functions. We never mentioned multiplying or dividing two functions. And so it turns out that's what we're going to do in 3.3. 3.3 is the product and quotient rules. How do we quickly find derivatives when we are multiplying two functions or when we are dividing two functions? And it turns out it's not as simple as you might think at first. The adding or subtracting, right, that's really nice. Like you just take them individually and then either add or subtract. That's not going to be the case with multiplying or dividing. It's not quite that simple. Okay, so for example, and we'll do these once we get the rules. Here's an example of multiplying or dividing. So f of x equals x to the third times e to the x. Right, we're going to think of these as two separate functions multiplied together when we take the derivative. Or in the next one, maybe f of x equals the natural log of x over x squared plus 1. So of course we're dividing two things there. Okay, let's look at the product rule. Here it is. We're trying to take the derivative of two functions being multiplied. So we've got f of x times g of x. And it's a little bit more complicated than what you would expect, right? So it turns out there are these two parts, and they're sort of like opposites. So they're kind of like symmetrical, if you will. So the first part, we take the derivative of the f, but then we multiply by g just the same as it was back here. So we're just copying the g of x right there. Then we add, and well, it's like we do the opposite. So we take f, just the same f that we saw back here, and multiply that by the derivative of the g. So you might read this f prime times g plus f times g prime. Okay, let's see an example. Let's see it in action. Let's look back at that first example I showed you just a moment ago. What if we said our function is x to the third times e to the x. And we notice we're multiplying two things. And I like to kind of visually do that for myself. So I underline the x to the third, and I underline the e to the x. So I can see there's my first function, there's my second. Now, it's easy to get confused with all like what's f and what's g. So we're calling this entire thing f of x. When we do the derivative here in just a second, we're thinking of the first one as f and the second as g. So, it's easy to get mixed up like what's f and, but the whole thing is f, but just this is f. And don't think of it that way. In the product rule, think first and second. So there's the first function and the second function. When we do the derivative, we do the derivative of the first times the second plus the first times the derivative of the second. Okay, so we got first and second. So here's our derivative, and let's talk through it. So f prime of x, right, the derivative of the whole thing, equals, and we're going to say, okay, what's the derivative of the first? What's the derivative of x to the third? Well, we're very familiar with that. That's 3x squared. And we're going to multiply, and I like to use a dot here just to help me visually sort of distinguish what's going on. So we've got 3x squared times, and we just copy the e to the x. So all we're doing is saying, okay, it's this derivative, but then this one just gets copied. Plus, and we do the opposite. We copy the x to the third, multiply. Now here we are taking a derivative. It just happens to be e to the x, whose derivative is also e to the x. And there it is. Now, maybe in our final answer, we don't like those dots. Or maybe you didn't like the dots to begin with. I don't know. We might just say 3. There's nothing really to simplify here, right? We just say 3x squared e to the x plus x to the third e to the x. That is our derivative function. Okay. That's a very simple one. Let's do another one. See a little bit more going on. Okay. What if we are multiplying two polynomials like so? So maybe we say y equals the quantity x squared plus 1 times the quantity 5x minus 2. So we could think of this as a first and a second. Okay. So how would the product rule tell us to take the derivative? Take the derivative of the first. Well, the derivative of x squared plus 1 is 2x plus 0. So we'll probably just say 2x. And then we're just going to copy the second, 5x minus 2. Then we add, and we're just going to copy the first one, multiply, and now take the derivative of 5x minus 2. Well, that derivative is simply 5. So there you go. And now you might think, well, couldn't we, multiply that out and simplify? Well, sure. That wouldn't be too hard. 2x times 5x is 10x squared, but then we're going to add another 5x squared. So 15x squared, and then we have minus 4x and plus 5. If we were to simplify, we would have it right there. Now, sort of on that note of multiplying out, maybe some of you are thinking, did we really need the product rule in the first place for this function's derivative? And the truth is, no, we didn't, right? We could have simplified here. We could have foiled all of that and just made it look like one long polynomial, and then taken the derivative just with the previous rules, and we could have gotten to the same answer. Yeah, we could, but why not practice the product rule in this case for our lecture purposes? And kind of highlights another point. There might be more than one way to take a derivative. Now, as we learn more and more rules, maybe you've got some options, and they should all get you to the same place in the end. Okay, very nice. Oh, I've got one more example, it turns out. Okay. You're going to see um, things like this once in a while in the homework and such. Kind of throwing a little bit of a curveball, a little something different. Let's say h of x equals natural log of x times f of x. So they don't tell us what that second function is. They just name it f of x. Okay, well, let's see what the product rule would do for us here. Natural log of x times f of x. So let's see, h prime of x. We'd say, okay, well, it's still first and second. So derivative of natural log x is 1 over x, and then we're just going to leave that one alone. Plus, we're going to just copy the natural log x times, and now we take the derivative here. But to take the derivative, well, what are we going to do? We're just going to say f prime of x. And there's our answer. So we have an f of x in it, and we have f prime of x. There we go. That's an h, by the way, h prime. Okay, very nice. That is the product rule. Let's talk about dividing. We call it the quotient rule. So you see what I've got over here. Just ignore that for a moment and look at the formula. So a quotient rule, we're dividing two functions, right? So we're going to say d over dx, big brackets, f of x over g of x. That is a g. Okay. And, if we start with a fraction, our derivative is going to be a fraction as well. Maybe that's not a huge surprise, but it's getting more complicated, right? These formulas. Okay, so how does this all work out? So think of it not so much as f and g, but high and low. All right. So we're going to begin with the g of x, the low, times f prime of x, the derivative of the high, minus f of x, just copy there, times the derivative of g, derivative of the low, and then that whole thing gets divided by g of x, the original g of x squared. Now that is very strange. Now I'm not going into any explanation behind the product rule or the quotient rule. We got a lot of explanation for those previous rules. If you're curious about why the product rule is what it is, like how would you prove it, or why the quotient rule is what it is, certainly you can come and talk to me about it, or these things aren't difficult to Google if you'd like to know those. And certainly I think really the product rule, they're very similar in the way they're both shown, and so I'd recommend start with the product rule, and then there'll be a similar theme, although a bit more complex, for the quotient rule in how you derive that formula. Okay, anyway, here it is for the quotient rule. Now you see my note there over on the side, and this is a helpful way to remember quotient rule. Students don't tend to struggle too much with the product rule in remembering how it goes, but the quotient rule is a different story, and the truth is the quotient rule is not forgiving. The product rule, you could say it's forgiving in a way. The quotient rule is not forgiving. And the big difference here is the subtraction. A lot of times people mix up, that it's g f prime of x first and then subtract f g prime. And they might end up, reversing those, or, there might be some other problems as well. Where if we go back to the product rule, that's not an issue, right? So in the product rule, if you do f prime g plus f g prime, Is it a big deal if you were to get these in the wrong position? If you did this one first, fg prime plus f prime g, right? That's not a problem because we're adding. So we could reverse those. And even sometimes, different teachers or different textbooks, they present this a little bit differently. I like this because I find it easiest to memorize, f prime g plus fg prime. But in other cases, you see some of these things moved around, like even maybe these are reversed or these are reversed, let alone, that kind of a flip. It's all the same thing because we're adding and multiplying, no big deal. Not the case with the quotient rule. We have to get this one right. There's no room for error. We can't switch those two. If we did, we'd get the negative result of what we should get. Okay, so what's a helpful way to remember this? And there's this limerick that you see out on the side here. So we're going to think of, again, the F as the high and the G as the low. And so the way the limerick goes, low D high, obviously D for derivative, low D high minus high D low, all over low squared, and away we go. And you got to have that little bit at the end. Oh, and away we go is critical. You got to remember that part. Once again, low D high minus high D low, all over low squared, and away we go. Why is the away we go necessary? Okay, because if you were to reverse these, it wouldn't rhyme. Okay, so the fact that this is low, that rhymes with go, right? Low, D low, go. If we were to switch them, it wouldn't rhyme. Let's do it the wrong way and you'll see. What if we start here? High D low minus low D high, all over low squared, and away we go. Right? High doesn't rhyme with go, right? So you get it right. Low D high minus high D low, all over low squared, and away we go. Okay. Let's try some of these examples. I don't think we're going to have time in this video. Let's do them in the next one.